Hello.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. First, mark your attendance.
मैम LMS ओपन नहीं हो रहा।
LMS ओपन नहीं हो रहा है।
जी मैम। नो मैम।
Mark your attendance. And Subhajit Bhui, I will mark your attendance.
Yes, ma'am.
मैम साइट ओपन नहीं हो रहा है।
Roshan Kumar.
यस मैम, ओपन नहीं हो रहा है।
Okay. Okay, then I stop the screen sharing and take a screenshot of your today's attendance, right? And after class,
यस सर।
I will mark your attendance.
ओके मैम।
Today's topic is DRB, means
डबली रेनफोर्स्ड बीम।
right. And what do you mean by doubly reinforced beam or section? Have you
कंप्रेशन
guys
और टेंशन दोनों जोन में रेनफोर्समेंट होगा।
right?
यस
And
मैम, कंप्रेशन और
when
टेंशन
we
दोनों जोन में
provide
रेनफोर्समेंट।
and okay, and when we provide doubly reinforced beam, and what are the criteria?
When reversal of load is applied, when bending moment is maximum, shape is restricted.
Your sound is not clear.
मैम एक्सिस
Ma'am, I
लोड
was
जब
telling
होगा
One by one. Please give your answer one by one.
Ma'am,
when
when
due to reversal
area
of
of the
loading,
beam,
1 second. Roshan Kumar, tell me. When we provide doubly reinforced section, and what are the criteria? Anyone have any idea when we provide doubly reinforced section?
ma'am, when depth of the beam is restricted and external moment is greater than singly reinforced moment, then we apply doubly reinforced section.
Okay. Right? And then again I repeat, what is doubly reinforced beam or section, and when we use doubly reinforced section for regular student? मैम मेरा अटेंडेंस नहीं हो पा रहा है। रोशन कुमार, आई विल मार्क योर अटेंडेंस। Now come to our topic. When size of beam is fixed, when the size of beam when the size of beam means beam's width and depth. Both are restricted when the size of beam both are restricted, or we can say fixed. And in that case we provide doubly reinforced beam. Doubly reinforced beam. And this type of beam and this type of beam has maximum moment of resistance. Moment of resistance means the ability to resist moment which occurs due to the external loading. The moment of resistance of balance section, right? Means we know moment of resistance is equivalent to QBD BD square, right? Sorry, here I write small d, which is effective depth, right? But in the case of doubly reinforced beam, moment of resistance is greater than the moment of resistance of balance section. And this type of beam is look like this. Here we provide free reinforcement in tension zone, and also we provide here reinforcement in compression zone. In that case, when we provide reinforcement in tension zone as well as in compression zone, in that case our beam is doubly reinforced beam. And also when the area of cross section of beam is restricted or limited, in that case we provide there a doubly reinforced section. Apart from this tension reinforcement and compression reinforcement, we also provide here a hanger bar. A hanger bar, right? Okay. This is your hanger bar. Hanger bar. To hold, we provide hanger bar in singly reinforced beam also, and this hanger bar holds the tension and compression reinforcement in one place. So we provide hanger bar here. In case of when we provide DRB, doubly reinforced beam, in our concrete structure, then we always, sorry, then, in case of doubly reinforced beam, if we provided, then we should design the doubly reinforced beam section, sorry, DRB, as a balanced section, and when in singly reinforced beam condition, SRB, if we provide SRB and then if we get our section is over reinforced section, in that case we avoid to provide over reinforced, because over reinforced section is susceptible to a brittle failure, or over reinforced section is subjected to a brittle failure. That's why we avoid to provide over reinforced section. Over reinforced section then instead of over reinforced beam, we prefer to provide doubly reinforced beam. If our section is or member is under reinforced, then this type of section gives enough warning before it's failed. But in case of over reinforced section, over reinforced beam, but in case of over reinforced beam, failures occur suddenly. Without giving any prior warning. So that we prefer again here doubly reinforced beam over over reinforced beam section. Over reinforced beam section. Right? These are the criteria or condition where we provide doubly reinforced section. Now we move to its analysis part. Doubly reinforced beam analysis part. Doubly reinforced beam analysis part. Number one, in case of doubly reinforced beam, the concrete and steel on tension side acts same as its act in singly reinforced section, right? Our first analysis is the concrete and reinforcement which we provided in tension zone or in tension side. The all provisions are same as in singly reinforced beam section. Is it clear? Means you are getting my point or not?
मैम एक बार रिपीट कीजिएगा मैम, कंप्रेशन साइड बोले या टेंशन साइड में?
Tension side. Here
एक बार फिर से
rain
रिपीट कर दीजिए मैम पूरा लाइन.
for when in case of doubly reinforced beam, the concrete and steel, if we provided, if word is wrong here, in doubly reinforced beam, concrete and steel in tension side or tension zone, they act same as a singly reinforced section, and the provisions are same, or the provisions are same as singly reinforced section. Means this part means tension part of doubly reinforced beam is same as that of singly reinforced section. Means for concrete, in case of doubly reinforced section, for concrete, note down, for concrete, CA, actual stress in concrete, is less than sigma CBC and equals to, less than and equals to sigma CBC, maybe when we consider doubly reinforced beam, when if our section is in balanced condition, or in over reinforced section, we prefer to provide a doubly reinforced beam in that section. So in tension side, the concrete and steel provisions are same as that of in singly reinforced section, right? Or for concrete, CA, actual stress in concrete, is equivalent to compressive bending stress in concrete, and maximum, where we know this is your maximum permissible stress, right? Permissible stress. And for steel, actual tensile stress which is acting on this section is less than sigma ST. where sigma st is the maximum permissible stresses. Sorry, maximum permissible tensile stress, tensile stress, and Ta is actual tensile stress acting on section. Right? For compression side, now we will see for compression side, in doubly reinforced beam, compression side means this is your neutral axis, and here I am providing 3 reinforcement in tension zone and 3 reinforcement in compression zone. And now we are talking about this section, not the lower part or not the tension part. Right? So for compression side, again I draw a doubly reinforced beam here to show all the dimensions. This is your neutral axis, and here I provide reinforcement in tension as well as in compression zone. And in case of doubly reinforced beam, the reinforcement provided in compression zone is denoted by ASC, and you also know that the reinforcement provided in tension zone, we denoted it as a AST. You all know that. And the distance from top compression fiber to the center of or CG of tension reinforcement, the distance between top compression fiber to center of tensile reinforcement, we denote this distance as, tell me, what we call this distance?
हम डी से डिनोट करते हैं उसको.
D, right. And
इफेक्टिव डेप्थ ऑफ बीम बोलेंगे मैम.
right, effective depth of beam. And the distance between CG of top reinforcement to the top compression fiber is denoted here DC. And we know this distance, as a, tell me,
Effective cover.
effective cover. Here I denote it as a D dash, right? And
D dash से भी
DC,
denote करते हैं ना मैम?
हाँ, notation is totally on you, but you mention D dash
Meaning
is your effective cover, DC is your effective cover in compression zone, D dash is your effective cover in tension zone. So, number 1 point for compression side, area of steel in terms of concrete area 1.5 MASC. Second, always mention where M is your modular ratio, ASC is your area of reinforcement provided in compression zone, and AST is area of the reinforcement provided in tension zone, right? Second one is stress in concrete stress in concrete at the location of compression steel here I denote it as a C dash, means in singly reinforced beam section we denote stress in concrete is C, or if the section is balanced, then C is equivalent to sigma BC, right? And T is equivalent to sigma ST.